Okay, so this is the first question from the homework that we're going to work on. So we have a simple looking function given to us. It's a linear function, x plus 5. First you have to fill the table with the output values. I think this is pretty easy, right guys? You just plug in x values and find out the y values or the output values. So when x is 0, it's going to be 0 plus 5. When x is 5, it's going to be 10. When x is 10, it's going to be 15, 17, and 25. This is where it gets a bit more interesting. So now what they're saying is which, so they're going to give you, for example, an x value, and then they're going to say what's the inverse's output going to be. Now remember, the job of an inverse is to take the output of the function and tell you what the input was. Okay? So for example, if you ask the inverse, what are you when x is 5? It's basically going to be answering what the input was when the output was 5 in the main function. Okay? So it's essentially the opposite. So the input of the inverse is the output of the function, and the input of the function is the output of the inverse, basically. So, which means that when they say that the inverse is 5, that essentially means that the input of the main function is 5, and the corresponding output of the main function is 10. Okay, so it's just reversed basically. So for Sophia, what do you think like what do I put here? What do you think?
15.
15 exactly. Because when the output of the inverse is 10, that essentially corresponds to the input of the function. And the input of the inverse will correspond to the output of the function. Okay. And for instance, Amy, what do you think we're gonna have here? Careful.
Um, would it be 12?
12 exactly. Because these two and these two are equal. So now what is gonna be here? Jessica, what do you think?
25.
25 exactly. Because when the output of the inverse is 20, that essentially means the input of the main function is 20. So the output of the function and the input of the inverse will correspond. Write down the equation of the inverse. Let's do that. Did you guys have trouble with the inverse?
Not
Anybody?
really.
Sophia?
No.
Yeah, because the inverse is like last class I also explained. So first you take your function, you write it down as sorry, you replace the output with x and you replace the input with y. Basically reverse them, and then make y the subject. That is it. This is your inverse. So you can, if they want you to write it down as f inverse, you can just replace the y with f inverse, and that's basically it. That is your f inverse. Now, given that p equals q plus 5, write down q in terms of p. I don't even know why they asked this question. It almost is so easy that it's confusing. All they're saying is that in this equation that seems very unrelated, make q the subject. So when someone says write q in terms of p, that means make q the subject. Okay? So we gotta basically leave q alone. Means I gotta subtract my 5 on both sides, and that's literally it. That's the answer. So any questions about this?
No.
Okay. If you guys are still kind of confused on how this thing works, or if you feel like it doesn't still make sense, then maybe in the next class we can do a bunch of inverse specific questions together just to make the idea more clear. Just let me know after the class if it still feels like, kind of blurry. Because
I
inverse is, uh-huh,
I wrote that's 5 minus p. Is that wrong?
5 minus p. So that would be wrong because look, if you do 5 minus p, what's your essential, like algebraically, what's your step? So what did you do to get 5 minus p is the question.
Um,
So like at this point, what I did was I subtracted 5 on both sides. Oh, the reason I did that is because I wanted to get rid of this guy from here and put it to the other side. So he canceled out from here. So you cannot get 5 minus p, and the only way you can get 5 minus p would be if you subtract p on both sides, which would make it look more like this, and then subtract q on both sides, but then you would not get q, you would get minus q,
okay.
right? So make
Yeah.
sure that you kind of follow the algebraic steps of doing the same thing to both sides of the equation, because you will always understand if something's wrong that way. If you break that rule, you've done something wrong, essentially. Okay, so that's 16. Any other questions about this?
No.
All right. Question 19, someone said, right?
Yeah.
Okay.
Oh, 27.
Nobody said 19?
I don't think so.
No, I said 19.
Yeah, okay. I remember the number. I don't remember the voices because there's many now.
It was
Right.
in 19. It was the part A, like 2 i's, and then
Okay.
C.
So the inverse stuff. Okay. So this one, and I'm assuming this one, right?
Yes.
Okay. So f of 1 is easy. It's just going to be 3 because f of 1 just means what's y when x is 1. F inverse of 1 means what is the x value when output is 1. Okay, that's what it essentially means. So that is the output, and they're asking you what's going to be the input for that output to come out. So for the output to be 1, the input was 5. So the answer is 5.
Mhm.
Okay. So you can think about it like this, like the inverse takes the y value and asks you what the x value is. And the function takes the x value and asks you what the y value is. So if you give the function 1, it's basically taking the 1 as an x value and telling you what the corresponding y value is. That's what a function's job is. An inverse's job is the opposite. An inverse takes the y value, so it's taking the y value and telling you what the corresponding x value is. Okay? So that's basically the idea. Now, if I tell you that f inverse of x is 2, that means that for some y value, the x value is 2. That's the idea. Because this mystery thing is the y value. And the corresponding x value is 2. Because again, an inverse takes the y value and gives you the corresponding x value. So what is the y value that has an x value of 2? This one. See? This y value gives you an x value of 2. You see what I mean? So for which y value? For for x equals 4. We have to say x because an inverse, of course, it takes a y value, but the name is still x. That's the confusing part. Okay, it makes it easier if you think about them as input and output. So for some output, the input value is 2 basically. You can think about it like this. So what is that output value? It's 4 because 4 has the input value of 2 basically. Does it make sense now?
Yes.
Okay. 27 next.
Yeah.
Yeah.
27 was, I remember Sophia was the last one who stayed in the class, and I was thinking about whether to give you this. And I decided to give it to you because it's a very difficult question. We haven't gone over trigonometry together yet, but still I wanted to kind of show you guys what this would be like. So for the first part, you should just use the calculator. It's the easiest way to do this. Okay. I wonder what this will look like actually. One second, I can find out.
That's kind of where I got stuck. I just did the graph and then I didn't know what to do.
Yeah, it's a bit tough. So using my very basic calculator, I can find out that my x-intercepts are 3.238, which is somewhere around here, and 2.16, which is somewhere around here. And since it's -5, that means it's an upside down parabola. Now, you see that the parabola meets your sign at 2 different places. The first place has an x value of this much, I don't know what that is, and the other intercept has an x value of whatever that is. Can't really see well, but it's somewhere in there, right? They've already told you one of those, 1.89, which is clearly this one. You see, it even looks like 1.89, right? But what's this one? That's the question, basically. How do we find it? Calculator. I mean, just plug in 3 sine. So there's a bunch of ways to do this. you can either plot the graph of this guy and the graph of this guy and find like and solve and try to find out what the intersections are. That'll tell you the other intersection. Either that, or you could go to the equation solver and solve this equation. So you could put both the functions equal to each other and solve that equation. So both ways you can get the other x value. That's essentially it. Is that clear?
Yeah.
For part B. Sophia? Sophia, can you hear me?
Yeah.
Yeah, okay. So part C now, we have a new function, which is a subtraction of g minus f, basically. Okay, this is also a calculator question, actually. The thing is, h of x is given as g minus f. G is this. And then f is this. So this is h. H is basically g minus f, right? Plot this, it'll look like something like that, I guess, or maybe something like that, I guess. You're supposed to find out the x values for which h of x is negative or 0. Okay, because that means when is it under the x-axis. Okay, so that's basically all they're asking. They're asking you when is h of x's graph under the x-axis. So again, you will do this on your calculator. You can trace it, find the x-intercepts. For example, if this is, I don't know, 4 and this is 2, you will say for all values between 2 and 4, it is under the x-axis. You see what I mean?
Mm-hmm.
Sophia, is this clear?
No.
No? Did you say no or did you say yeah?
No.
Ah, okay. So look, h of x is a new function. That's obvious, right? It's a new function that's created by using g and f, right? So h of x is basically this thing minus this thing. So we get this new function. Is that clear?
No.
Oh, okay. So you have g of x. This is like the definition of g of x, and this is the definition of f of x, right?
Mm.
The thing is, it says that h of x is equal to g of x minus f of x. G of x is simply minus 5x squared plus 27x minus 35, and f of x is simply 3 sine 2x, right?
Oh, okay.
So h of x is just a subtraction of both of them. See, that's the g of x part minus that's the f of x part. So the function definition makes sense now, right?
Mm.
By the way, this is very important. I mean, this is not very like common. It's a pretty difficult thing. These kind of questions where they make a new function out of a bunch of functions, but kind of try to get used to this because they will do this in AI often. So they could have also said, like, for example, h of x is the square root of g of x. So you are supposed to understand that it essentially means take all of g of x, that's g of x, right? And put a square root over it. That's h of x now. This is a new function I've made by using an ingredient from earlier, g of x. Okay? So you can like construct new functions using old functions. Okay? So now that we have realized that this is a new function, forget about f and g now. We don't need to worry about them. Now, given that h of x is less than or equal to 0, whenever someone says a function is less than 0 or more than 0, what they're talking about is the y values of the function, okay? So if I tell you that h of x is less than or equal to 0, that essentially means that the graph of h of x is negative, right? In this region, basically. See, it's under the x-axis, meaning it's in the negative sides, -1, -2, -3. So that's what they mean here. Now, given that this function is negative for this range, I don't know what range it is, but for some x values, the function is negative, meaning the function is doing some funky stuff, but for some x values between this x value and this x value, the function is negative. You see this part of the function? It's below the x-axis, which means that it's in the negative section. Does that make sense now? So this is what we call h of x being less than 0 or less than or equal to 0, because it's in the negative side, it's in the negative y values. Does this make sense now? I mean, so far. I haven't finished the explanation, but does this part make sense? Wait, can you hear me? Sophia?
Yeah.
Okay. So does this part make sense?
Somewhat.
Somewhat. Okay. So when I say that a function is less than or equal to 0 or a function is less than 0, that means the y values of the function. Okay. And when I say that a y value of a function is less than 0, it means that it's under the x-axis. Because look, this is where the negative y values form, right? That's how the graph works. So when I say a function is less than 0, that means it's under the x-axis. Okay?
Mm.
That makes sense?
Yeah.
So what they're saying is that this function h of x is negative, meaning below the x-axis, for this range only. And then they're saying, what is that range? For what values of x is the function below the x-axis, basically? So what you're supposed to do is you're supposed to plot the function on a graph and basically just trace and see where is the function reaching below the x-axis. So like, when does this happen? So what are the x values for which the function is below the x-axis in the negative section? So you will find out this value and this value, and obviously, as you can see, these values are essentially x-intercepts, aren't they?
Yeah.
So you're supposed to find the x-intercepts, and using those x-intercepts, you're supposed to say that, for example, if this is 2 and this is 4, you will say that for all values between 2 and 4, the function is below the x-axis. That's the idea.
Mm.
Okay, so we can take a look at this part of the question separately also, if you still have trouble with it, but try to sketch this graph and find out the x values where this graph is below the x-axis. Okay, so whatever this x value is and whatever this x, and you can see that between those x values the graph is below the x-axis, so it's negative basically. So you will say that between p and q, whatever these values are, the function is negative. Is it clear now?
Yeah. So it's
Okay.
2 and 4.
Sorry?
Is it 2 and 4?
I mean, I'm just guessing. You'll have to find the, well, we'll have to find the x-intercepts using this graph itself. So plot it into your calculator and find the x-intercepts. Those are the numbers that you'll put here actually, because I don't know what they are. Okay?
Yeah.
All right. So now we have to work on the next idea, which will be about exponentials and logarithms. Let me check first if this is okay. So we're going to start working on exponentials and logarithms now. Before we talk about them, actually, let's start a new recording for